All right, so now we're going to do the properties of rectangles and how they kind of build. The very first one is kind of a common sense one because of our definitions from earlier in the chapter, but I want you to think about how common sense this is. It says if quadrilateral is a rectangle, then it's a parallelogram. So understand all rectangles are parallelograms. And the reason why is how we can prove it. Why? Do I have two pairs of opposite angles in that quadrilateral? Yes, we do. Well, if I have two pairs of opposite angles congruent, is that quadrilateral a parallelogram? Yeah, it is, because that's how you prove quadrilaterals are parallelograms. So I just say why? I have two pairs of opposite angles congruent. So it's a cool thing that we can actually prove. Now the next theorem is really important for you to know because this is kind of like the new piece of information that you've ever had. It says if a parallelogram is a rectangle, then its diagonals are congruent. So the cool thing is I know this diagonal is congruent to this one. But there's a step further I actually can physically think when I'm doing this. If they are congruent, okay, no big deal. But it's also, every rectangle is a parallelogram. Can't I also prove that all four of those segments are the same size? As a result, I have these four isosceles triangles I can work with. That might actually help us solve for angles and stuff later, or maybe missing line segments later. So it's really helpful for us when we work with these. All right, let's go on one more with a rectangle. Okay, and the next one is just the converse of what we've been working with. And it's the cool thing of just really the converse of the one above. It helps us classify things. It's the following. If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So basically, if all you know, I'm not drawing that very well, so let me do it this way. If you have this parallelogram, and you can show that the two diagonals are the same size, you automatically know that's a rectangle. So that's basically what they're saying. So just remember, they're going to be of the equal length. Now, what do I do with this? Distance formula. So we'll actually talk about the distance formula with the two of those. Then the next definition we had is a rhombus. Now remember, a rhombus is a quadrilateral with four congruent sides. For some reason, rhombuses like to show up a lot when we're working with anything in the next couple chapters. And so literally, just make sure you know all of this. It's just huge. And these properties of a rhombus are something you'll see over and over again. ACT, entrance exams, all of those. So when you have a rhombus, the first thing you should do is make sure you mark all the sides congruent. Now let's go ahead and let's go through the theorems. Again, the first theorem, common sense. A rhombus is a parallelogram, basically. Why? Once again, think about it. I have a couple things I can do, but this is the one that makes the most sense. Do I have two pairs of opposite sides congruent? Yeah. Therefore, it's a parallelogram. So why does that work? We have two pairs of opposite sides congruent. It's just a way of proving it. So here would be one pair, and there would be our other pair. Now, when I have a rhombus, I automatically mark that all the sides are congruent. But with that, I also know every single time that I have good parallelogram also. All right, let's do the next two properties. These are kind of critical that we know. It says if a parallelogram is a rhombus, then its diagonals are perpendicular. So no matter what, they do bisect each other, but they don't have to be congruent. But the one thing they're going to be is they're always going to be perpendicular. So if they draw in both diagonals, I automatically put in a right angle every single time. So, and the cool thing is you'd actually end up having four right triangles that are all the same too. All right, the next one. If a parallelogram is a rhombus, then each diagonal bisects an opposite pair of angles. Now, What that means is that we're going to have a whole bunch of congruent angles, because remember, opposite angles of a parallelogram, this big angle and this big angle, would be congruent. But that diagonal bisects them. So I have this one and this one are the same. 3 and 4 are the same. And this is actually kind of logical, because do you see the big isosceles triangles? Aren't those base angles of an isosceles triangle? Yeah, and they get to be congruent. So it's kind of a cool thing that follows. But it can also go this other way. So those two would be the same, and these two would be the same. So we have these opposite pairs of angles being bisected. So we actually can mark those and assume those right away also. Okay, we're almost done. We have 2 more pages. We'll see how we go.